Dear students, in this video I am going to explain Fajan's rules and Lewis representation, ionic bond, resonance structures, difference between sigma and pi bonds. Let me explain Fajan's rules first. According to Fajan's rule, an ionic bond is formed by a compound with low positive charge, a large cation and a small anion. A covalent bond is formed by a compound with high positive charge, a small cation and large anion. So it is easy to learn the conditions for covalent bond formed is high positive charge, small cation and large anion are completely different and opposite to the conditions form ionic bond are low positive charge, large cation and small anion. Example, size of the ion. Compared to cesium, rubidium, potassium and sodium, lithium is small cation. So according to Fajan's rule, lithium chloride has more covalent character. In the second example, charge of cation is less for sodium. So according to Fajan's rule, silicon chloride has high covalent character because silicon has high positive charge. To understand Fajan's rules, so there is a summary. The first one is small cation favors covalent nature and large anion favors covalent nature. Similarly, high charge on ion favors covalent nature. Next, Lewis representation of simple molecules. We all know about Lewis dot structures. In that, only valence electrons are shown as a dots around the central atom. Here I am giving you Lewis dot structures for molecules. Count the number of electrons around every atom in the molecule. Some electrons are in bonds and some electrons are in dots. Here very important few molecules are given. Hydrogen sulfide, sulfur is central atom. Around central atom 2 bonded pairs and 2 lone pairs are there. Lone pairs are represented in dots. So 4 dots, that means 2 lone pairs, 2 lines. These 2 lines represent covalent bonds, therefore 8 electrons. 2 bonded pairs, 2 lone pairs. Similarly, silicon tetrachloride also represents as shown in figure. So beryllium difluoride, CO3 2 minus ion and formic acid. So these are the Lewis representation for some of the important molecules which are frequently asked for exams. The next important is Lewis dot structure for sulfur. Sulfur atomic number is 16. So 2, 8, 6 is the electronic configuration. It has 6 electrons in the valence cell. So therefore 6 dots are shown around the sulfur in this dot structure. When sulfur gets 2 electrons, it will become S2 minus. So S2 minus ion dot structure is shown here. Here 2 multiplication symbols, that means 2x cross marks represents gained electrons. Next one, ionic bond. We all know that ionic bond is an electrostatic attraction between 2 atoms, where the one atom transfers an electron to the other atom. The best example for ionic bond is sodium chloride. Sodium always wants to lose 1 electron and chlorine always wants to gain 1 electron. Therefore, when sodium and chlorine approach to each other, 1 electron transfers from sodium to chlorine, and sodium gets partially positive charge and chlorine gets partially negative charge. There is an attraction between 2 opposite charges. This electrostatic attraction force is called ionic bond. Ionic bond is formed only between metal and non-metal. The electronegativity difference is equal to 1.7 or more than 1.7. Here I am giving you some of the important conditions required to formation of ionic bond. Please read carefully and note down. This is very important for exams. I will give you one point here, that is the difference of electronegativity between 2 elements must be greater than or equal to 1.7. If the difference greater than 1.7, definitely the 2 elements always forms ionic compound. The next important one, if you want to write this, pause the video and note down these points into your notes. Next one, properties of ionic bond. There are 5 points were given. The first and last points are very important. Ionic compounds have high boiling and melting points because they are very strong and require a lot of energy to break. And last point, ionic compounds usually dissolved in water and are not insoluble in solvents like oil, petrol, kerosene and etc. So if you want to take down these points into your notes, pause the video and take down. Next one, resonance, very important phenomena. The phenomena of existence of a molecule in many structures due to delocalization of electrons is called resonance. Here I am giving you NO2 resonance structures and NO3 minus resonance structures. In NO2 resonance structures, around nitrogen, there is 1 coordinate covalent bond is shown in arrow mark and other 2 bonds double bond. In the first diagram, double bond on the left side, and the second diagram, double bond on the right side. These 2 are resonance structures for NO2, and NO3 resonance structures are also given, very important structures. And SO3 resonance structures. These 3 are SO3 resonance structures. The number of structures increase and also resonance energy is also increased for the molecule. Next one. So sigma and pi bond. Very important differences are given here. I will read out only 2-3 differences. The first one is very important. It is formed by end-to-end overlap of orbitals, and pi bond is formed lateral overlap of orbitals. Any 2 orbitals can form sigma bond along with central axis, but pi bond are formed overlap of only p orbitals.